exothermic versus endothermic, a particulate view. Now let's do some review and some slightly new coverage of exothermic versus endothermic. So we're going to remind you what endothermic versus exothermic means. Of course, you've heard these terms in previous classes, but we want to review them now and also look at how these terms are related to the enthalpy and the bond enthalpy. So as a quick review, we know that endothermic is a positive delta H, or it's taking energy in. These are going to generally feel cold. So for instance, ice melting is an endothermic reaction. Exothermic has a negative delta H. It's releasing energy into the environment. These are generally going to feel warm. So for instance, a candle burning is exothermic. Meanwhile, an ice cube melting is endothermic. This hot versus cold isn't always true, but it does kind of help a little bit. What I want to add to this now is why are some reactions exothermic and some reactions endothermic? You have all the pieces of this already, and this is just kind of fitting them together for you. So, of course, some reactions are endothermic and some reactions are exothermic. Let's talk through it and do an example using the enthalpy of formation to calculate the enthalpy of a reaction and then discuss the results. So let's say we have the following reaction. Take a look at this for a moment. We can look up the enthalpies of formation for everything in this reaction. And then to calculate the enthalpy of the reaction, we can simply do products minus reactants. So let's do this. We have our total on each side. And if you're saying, where did you get those values from? Well, they're on the slide. But if you were doing this in a homework, you would go to the back of your book and you would look them up. From here, we can take the difference of them. We'll do the products minus the reactants to get our negative 566 kilojoules per mole. Now pay attention to the negative sign here. This means that energy is released, that the energy is going into the surroundings. Remember what we did with our money example, and we said if you have a negative bank account, you're losing money, you're giving money, maybe you're shopping, maybe you're giving it to somebody. But if your bank account is being positively changed, then you're putting money into it. And that's how we can remember the negative versus positive. So this negative is meaning that energy is released, that it's going out into the surroundings, and therefore the reaction is exothermic. Now, where did all of that extra energy go? It's going out into the surroundings, and this is what gives us that exothermic versus endothermic reactions. It's all based on the values of the product's enthalpy versus the values of the reactant's enthalpy. So this is just going to restate and summarize this concept. An exothermic reaction has a lower energy after the rearrangement. This means that the energy difference is going to be released. Meanwhile, an endothermic reaction, its products have a higher energy after the rearrangement, which means that the energy is absorbed. So for exothermic, the products is lower than where it started. For endothermic, the products is higher than where it started. So a very quick review of our review, let's say. The delta H is always going to be estimated by comparing the energy that is absorbed to break bonds versus the energy that is emitted from making new bonds. We have 3 different ways of doing that, but they're all doing the exact same thing, comparing bonds broken to bonds formed. In an endothermic reaction, when you compare that balance, your products are going to have a higher energy. It took in energy to get to your products. So those are going to feel cold to us because it's actually using the energy of your body heat to do the reaction. Meanwhile, an exothermic reaction has a negative delta H because the energy is going to go down in the products. So this feels warm because it's releasing energy. So if you put your hands on it, your hands are absorbing the energy from the reaction.